All right, let's look at section 1.3, part 2. All right, sample size. So sample size is going to become very important later on. Sample size is how many subjects we look at in the study or how many subjects we treat. It's very important that that is big enough for us to be able to infer, but costs may keep that from being too big, so we might have to judge exactly how many we need, but that's sample size, and we'll see that more later. Replication is when we do a repetition of an experiment under similar conditions. So you've got a flashcard there for that also. All right, we have a company wants to test the effectiveness of a new gum developed to help people quit smoking. Identify the potential problems with each experimental design. So the first one, it says a company identifies 10 adults who are heavy smokers. 5 of the subjects are given the new gum, and the other 5 subjects are given the placebo. After 2 months, the subjects are evaluated, and it is found that the 5 subjects using the new gum have quit smoking. Well, that's great, but that's way too tiny of a sample size. Like only looking at 10 adults total, that's not large enough to validate the results of the experiment. So they would have to replicate that. All right, then we have a company identifies 1,000 adults who are heavy smokers. The subjects are divided into blocks according to gender. So the females are given the new gum and the males are given the placebo. After 2 months, a significant number of female subjects have quit smoking. Well, those two groups are not similar. Men and women are made very differently. And so they should have divided those into blocks by gender and had some of the females be in the experimental and the control group, and then some of the males be in both as well for them to have a decent experiment there. All right, a little more vocabulary. I know this chapter is full of vocabulary. So a census is a count or measure of an entire population. So you're seeing things all over right now where they are trying to get everyone to fill out their census. And of course, we have to do it from home or on the internet because we can't go into the offices and do that. But we need to know that. We need to know that for school districts. We need to know that for politicians, for their districts. There's lots of reasons. States want to know how many people, counties. So that is very important. It's very difficult. It's very costly because you're trying to talk to every single person in the population. Of course, the sampling would be just to talk to part of the population. For our census, we don't want to do that. But for most of our studies, that's what we're going to do. We do have issues. There's going to be some sampling errors. We're going to look at those as we go along. But you've got to look at sample size. You've got to look like that last one where they gave the females the gum and not the men. You've got to really look at your sample and make sure that it's spread out across your population and that it's really representative of your population. All right, so now we're going to look at stratified sample. Now, the way I set up my flashcards is I went ahead and drew pictures of some of these. So with a stratified sampling, what's going to happen is we have different groups. Okay, so in this case, we have low income, we have middle income, and we have high income. Well, the middle income have the most people, according to this, right? You see that you have more houses. The low income have 5 houses. The middle income has 7 houses, and the high income have 5. So by stratifying a sample, we're not going to take the same number from each. We're not going to just take 2 houses from each because that would misrepresent the middle group because the middle group has more people. So we're going to take 2 houses from the low income. We're going to take 3 from the middle to denote that we have more people in that area, and then 2 in the high income. So that is called a stratified sample. And you can see here on my flashcard, it says divide into groups. They may be different sizes, and then randomly select a sample from each group. Okay, so this is a cluster sample. It's not always good. It just depends on what you're doing. So these are zip code zones. So we have 4 different zip codes here in this one county. And so the population naturally is divided into these zip codes. We're going to call them clusters. We do have to be careful, though. If we only talk to one zone, that might not be representative of the whole county. And so you just have to look at your study, look at your results, and see if maybe you need to go back to a different sampling technique. So this is a systematic sample. What happens is, let's say we have all these houses on the street, and we're just going to go talk to every 5th house. Okay, this is every 100th, but let's say we're just going to talk to every 5th house. So we have to start somewhere. We randomly choose a house to start, and then we go to every 5th house. Okay. And so for the flashcard, what I wrote is the population is ordered, and then we pick members at regular intervals, like every 3rd house. So just for you to have a little cue of what you're looking at for this sampling. Okay, then we have what we call convenience sampling. So this would be if I want to ask students if they like biology. Okay, and so I just stand outside a building, and as they come out, I ask them. I say, okay, do you like biology? Well, if I stand outside the building where we have all our science classes, then I'm probably going to have a lot of people who like biology coming out of there because that's the science building. Maybe not. But if I go stand out in front of the music building, I'm probably not going to have as many people who like biology. So we have a possible bias, and that's because you probably have a lot of science majors if you're standing outside the science building. So convenience sampling isn't always good. We have to be careful and see if there's a bias. All right, let's look at a problem here. So we are doing a study to determine the opinions of students at your school regarding stem cell research. Identify the sampling technique you are using. So for number 1, we divide the student population with respect to majors, okay, and randomly select randomly select and question some students in each major, right? So we divide them into the different majors, and then we randomly select out of those majors so that we get a representative across the board. So this is called a stratified sample. Okay, we looked at that. All right, the next one was you assign each student a number and generate random numbers. You then question each student whose number is randomly selected. This one wasn't in my slides. So this is actually called a simple random sample. This is kind of what happens when they're calling your house. They randomly grab your phone number. So each sample of the same size has an equal chance of being selected, and each student has an equal chance of being selected because you just gave them numbers, right? So let's say you've got 20 students, you gave them 1 through 20, and then you just randomly generate the numbers. So that is called a simple random sample. Okay, then finally, you select students who are in your biology class. All right, well, that's convenience. That means you didn't put much thinking into it at all. You just show up at your biology class, you ask how many of them have an opinion regarding stem cell research, and so that would be a convenience sample. And since it's a biology class, you would probably get a biased answer on that. Let's look at another problem. Here we are questioning students as they leave an academic building. A researcher asked 371 students about their dating habits. Okay, so what type of sampling is used? Well, because they're just standing in front of a building and just as people come out, they ask them, that is going to be a convenience sampling. And then we have what potential sources of bias. Now notice up here, there's a circle next to the letters. That means you only can pick one answer. So if there's a circle in front of the multiple choice, you can only pick one answer. Down here, we have little squares. With the squares, that means that we can answer more than one. So let's see here. We're looking at bias. The first one says the sample only consists of members of the population that are easy to get. These members may not be representative of the population. That's true. Because of the personal nature of the question, students may not answer honestly. Okay, so when you're developing a survey, the questions are really important. If you write the questions with a bias, you're going to kind of guide people how to answer, and that's not good. You need unbiased questions. University students may not be representative of all people in their age group. Well, that could be true, but that's not a bias here. There are no potential sources of bias. No, so it would be the first two. Oh, here we go. Here's a question I was talking about. So this says, why is eating carrots good for you? That's biased because you're implying that eating carrots is good for you. So this is definitely biased. We should say, what are we going to say? Do you think that eating carrots is good for you? No. Why is eating carrots bad for you? Oh my goodness, that's worse. How do you think eating carrots affects your health? That looks better. Do you think that eating carrots is bad for you? All right, so it's C. Right, we don't want to sway them one way or another. All right, so now's my slide for simple random sample. It's a little late. So we use random numbers, and nowadays we use computer software programs, but this is just an example. Back in the day when we didn't have all these computers, we had a table of random numbers. And that is how we picked. Like if we had 1,000 people and we only wanted to talk to 100 of them, we would assign them numbers, and then we would use the random number generator to see who we would talk to. All right, so we have 731 students currently enrolled in a statistics course at your school. You wish to form a sample of 8 students to answer some survey questions. Select the students who will belong to the simple random sample. All right, so you're going to assign numbers 1 to 731 to all the students in the course, and then you're going to use a random number generator to pick who you're going to talk to. Now, since you have 3 digits, right, you could go all the way up to 731, which is 3 digits. You have to grab 3 digits inside this random number generator. So you're going to go to a certain row. This is our row of random numbers from that table, and we're going to grab 3 digits. Well, 3 digits would be 719. So that's the first person we're going to talk to. We're going to talk to the person with number 719. Okay, then we're going to go, and it doesn't matter that there's a space in between. Then we're going to go to the next 3 numbers. Well, the next 3 numbers would give me 662. So I'm going to go ahead and talk to the student with the number 662. Okay, then I'm going to go to the next one. The next one is 738, and I would keep going. Now, if for some reason it was a duplicate, I would skip that. Okay, the next one is 650. I'm only going to do one more. And then the next one is 004. So that would be the person with the number 4. All right, we're going to try a problem like this too. All right, so this is a problem from my stat lab. A researcher wants to study the effects of sleep deprivation on motor skills. 9 people volunteer for the experiment. Okay, and so I went ahead and typed those people here so that we could see. Right, so that's right here. We have Amanda, Brian, all the way down to Ivan. Okay, so I went ahead and wrote them, and I gave them numbers 1 through 9. Okay, so they say use the second row of digits. So you have to watch this because sometimes they want you to use the first row, sometimes they want the second row, but this one says it wants the second row of digits of the random number table below to select a simple random sample of the 3 subjects. The other 6 subjects will go into the control group. Okay, so we're only picking 3. So I'm going to go ahead and rewrite this random number row here. So I want that, the second row. So I'm going to grab 6, 7, 2, 7, 8, and then I'll see if I need more. Now, I only have one digit, right? Because these guys are 1 through 9. If I had had a 10th person, then I would need 2 digits, but I only need 1 digit because it's 1 through 9. So what we're going to do is we need to grab 3 people. So because I only need 1 digit, I'm going to put a line here. That means the person who's number 6 is going to get to be in the experimental group. Then I'm going to grab number 7. And finally, I'm going to grab number 2. Now, this is what I was talking about on the last slide. If I was picking more people, I would not repeat the 7, okay, because I already picked the 7. So I would just ignore the 7 and I would pick number 8. Okay, so these are the numbers that we're going to pick. We're going to pick the 6th person, the 7th person, and the 2nd person, and that's based on this table of random numbers. But again, be careful and read the fine print, because sometimes they'll ask you to use the first row, in which case we would have used this first piece of data, or they might ask you to use the third row. So you've got to watch and see what they want. So then down here, they just want us to give the names of those people. So this person with number 6 was Fred, number 7 was George, and number 2 is Brian. So those are the 3 people who are in the experimental group. The rest of them are going to go in the control group.